Topic number 5, inequalities. Question 1. Craig went bowling with $25 to spend. He rented shoes for $5.25 and paid $4 for each game. What is the greatest number of games Craig could have played? Okay, so what Craig spends has to be less than, that's the symbol for less than, has to be less than 25 bucks. And Craig is going to pay for games and shoes. He's going to pay for X number of games and one pair of shoes. So X number of games for $4. It says $4 for each game, $5.25 for the shoes and $4 for each game. So he's going to spend X games, and each game is going to cost him $4. So 4 times X plus $5.25 for the shoes. How do we solve this inequality? Well, just like an equation, we're going to subtract $5.25 from either side in the first instance. That's good legal math. And then we get X times 4 has to be, again, less than, still less than $19.75. What do we do now? We divide by 4. If we divide by 4, that means X equals, this is the number of games, remember, because the number of games times $4, the number of games has to be less than 4.9375. So if it has to be less than 4.9375, it cannot be 5. The number that's highest, that's the number of games. Remember, you can't bowl 4.5 games, right? You either bowl a game or you don't. You pay for a game or you don't. The number that is the greatest number, less than 4.9375, is, of course, 4. And you're good. Question 2. For her cell phone plan, Heather spends $30 per month plus 5 cents per text. She wants to keep her bill under $60 per month. Which inequality represents the number of texts T Heather can send each month while staying within her budget? Okay, so the amount Heather spends has to be less than 60 bucks. It's supposed to be less than 60 bucks. And she's going to spend money on texts, sending texts, and the flat fee. What is her flat fee? Her flat fee is 30 bucks and 5 cents per text. Okay, so T times texts plus flat fee, got to be less than 60. T times 5 cents plus 30 is less than 60. How do I solve this? Again, I solve it by simply subtracting 30 from either side in the first instance, and then I have T times 5 cents, or $0.05. Still has to be less than 30. How do I solve for T? Well, dividing by 0.05 from either side is a good step. Remember, T times a number divided by that same number will just give it be T times 1, or just T by itself. And whatever I do to one side of the equation, I have to do the same thing to the other side of the equation. And what do I get? I get T is less than 600. And, you know, we can do this out longhand, so T is less than 600. That's my answer. We can do it out longhand too, just as a review. It might be worthwhile to do. So if we have 30, remember here, 30 divided by 0.05. Let's just do it out. 30 divided by 0.05. So what are we going to do in the first, as our first step? We're going to move the decimal point 1, 2 spaces. And if we move that decimal point in this number 2 spaces, we're going to have to move that decimal point 2 spaces. So 1, 2. And we go from having 0.05 out here to 5, and we go from having 30 in here to 3,000. So 30 divided by 0.05 becomes 3,000 divided by 5. And then we have, how many times does this 5 go into 3? 0 times, but it goes into 30 6 times. And 6 times 5 is 30. 0. Bring down the 0. 0. You know, you can just add the zeros in, or you can actually pull them out and do 0, 0, 0 if you want. And your answer is 600. So T is less than 600. So Heather has to send less than 600 texts for her phone bill to be under $60 per month. Question 3. Ben earns $9 per hour and $6 for each delivery he makes. He wants to earn more than $155 in an 8-hour workday. What is the least number of deliveries he must make to reach his goal? Okay, so what do we have? We have Ben's earnings. He wants them to be greater. So this is the greater than sign, greater than $155. And what are Ben's earnings? It's hourly wages times the number of deliveries. No. Hourly wages plus the number of deliveries, right? He earns $9 per hour plus $6 for each delivery. So he earns $9 per hour times the number of hours, per $6 per delivery times the number of deliveries. And how many hours does he work? He works an 8-hour workday, right? Because it says he wants to earn more than $155 in an 8-hour workday. So we have $9 per hour in an 8-hour workday plus $6 per delivery, and we need to find X number of deliveries, and all of that has to be greater than 155. Press pause if you need to. I know we're going quick. What do we do now? Well, we have 9 times 8. That's just set up for us. So let's do that. That equals 72. And we have 6 times X number of deliveries, right? So 6 times X number of deliveries plus 72 is going to be greater than 155. Now, once we get to this step here, that looks super familiar. That looks like the form that we've been doing all year, and we can just subtract 72 from either side. That sets us up, if 72 taken out of 155 gets us to 83. So we have 6x, whatever x is going to be greater than 83. How do we solve for this? We just divide each side by 6. 6x divided by 6, that just becomes 1x or x. And 83 divided by 6, plug that in our calculator and do it out longhand. We get 13.83333333. So we have X needs to be greater than 13.8333. Remember, it's greater than because Ben wants to earn more than $155. So what number out here is greater than 13.8333? 14 is. And we're good. All right, on to question 4. Addison wants to ride her bike more than 80 miles per week. And I think, I should make a bigger focus on these more than or less than words. These are really key words. Remember up here we had Ben wanting to earn more than 155. On the first page we had less than. Here it's more than 80 miles per week. So she wants to go more than 80 miles per week. We got to really focus on these keywords in inequality questions. In a way, they're the most important words out there, but numbers are important too. So she wants to go more than 80 miles this week. She has already ridden her bicycle 18 miles, which inequality could be used to determine the mean or average number of miles M she would need to ride her bicycle each day for 6 more days to achieve her goal. Okay. So her total miles wants to be greater than 80. She wants to go more than 80 miles. Miles to do plus miles already done is going to be greater than 80. Now this is kind of a unique question, right? Because normally they're, this amount of money, that amount of money, and we'll add them together. Here it's miles to do plus miles already done. But still you're going to have one term plus 18 is greater than 80. And it's A, right? No, you gotta focus on the sign. Don't choose A. That's a really tempting distractor that they throw in there as the A distractor, just because a lot of people are going to be like, oh, 6M plus 18, there we go. I know it, but it's not that. It's C. And we're good. Okay, question 5. A trailer will be used to transport several 40-kilogram crates to a store. The greatest amount of weight that can be loaded onto the trailer is 1,050 kilograms. An 82-kilogram crate has already been loaded onto the trailer. What is the greatest number of 40-kilogram crates that can also be loaded onto the trailer? So what do we have? We have a big trailer. I'll draw it out because, you know, why not? A big trailer. You have an 82 kilogram crate that's already been put on there, and you have these 40 kilogram crates. You want to see how many you can put on the trailer in addition to the 82 kilogram crate, and everything has to be less than 1,050 kilograms, because if it's more, then these tires blow out and the trailer won't go and the store won't get its products, and that'll be bad. So it's got to be less than 1,050. And if you're having trouble to determine whether or not this is less than or greater than, well, just think about what your choices are. Is it possible that the trailer can roll with a very small amount of weight? Of course. Is it possible that the trailer could roll with a really large amount of weight? No. It has to be there is some limit of weight. So if we had this symbol here, that would mean your answer could be basically infinity, or you could have 1,000,000 40-gram crates and the trailer would still run. That's not plausible. So putting in extreme numbers there, 0 or 1 40-gram crate, would that work? Yes, that could work. And 1,000,000 or 1,000,001 crates, no, that couldn't work. So that's one helpful trick to make sure we have the right greater than or less than sign. Okay, so some number of crates, adding them all up, their weight, is going to be less than 1,050. And like I said, we had 40 kilogram crates times a certain number, right? So this is going to be C or X or some variable, some number of crates, plus 82, because we already have that 82 guy in there. It's 182 guy, so it's 82 times 1, or just 182 guy, is going to be less than 1,050. All right, so 40C plus 82 is got to be less than 1,050. How do we solve this problem? Well, simply we just minus 82 from either side, and that gets us, this cancels out, so 40C has got to be less than 968. What do we do now? Simple. Divide each side by 40. 40 divided by 40 is 1. 1 times C is just C, so that cancels out. And 968 divided by 40 is 24.2. So C has got to be less than 24.2. Remember, our less than signs just followed all the way through. So what number in our answers is less than 24.2? C, or A. And we're good. And question 6, Harper has $15 to spend at the grocery store. She is going to buy bags of fruit that cost $4.75 each and 1 box of crackers that cost $3.50. Write and solve an inequality that models this situation and could be used to determine the maximum number of bags of fruit B Harper can buy. Okay, so we have to write and solve an inequality. So you just can't solve it. You can't do it on scrap paper and just say, oh, here's my answer. And you can't just write out the inequality. You have to do both, and you have to pay attention to what the question is specifically asking you. All right, so let's do it. Here we go. Food has to be less than $15, right? Because Harper only has $15 to spend. What food is Harper buying? Well, she's buying fruit and crackers. And it has to be less than 15 bucks. She has to buy B bags of fruit, and each bag of fruit costs $4.75 plus $3.50 is going to be less than $15. And there's my inequality that we can solve, and we're good to go. So how do I solve this inequality? Well, I subtract, remember, because it's 1 box of crackers for $3.50. It says right up here, each box of crackers costs $3.50. 1 box of crackers for $3.50. And how many bags of fruit for $4.75 each. It's got to all be less than 15 bucks. How do I solve this inequality? Subtract 350 from either side. Whatever you do to one side of the equation, you got to do the same thing to the other side of the equation. 350 plus 350 minus 350, that cancels out. 15 minus 350 is 1150, so I have b times 475 is still less than 1150. What do I do now? I divide each side by 475. That makes sense, right? Because I have b times 475. If I divide by 475, I just have b left. And if I have 1150, divide by 475, I will get my answer. And it's b is less than 2.42105, and the number keeps on going. So B, the number of bags of fruit has got to be less than 2.42105. But you can't buy 0.42105 bag of fruit. You can only buy a whole number bag of fruit. So your final answer is going to be Harper can buy a maximum of 2 bags of fruit. And we're good.